Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video, another video in our series dealing with logarithms, is going to present a proof of the change of base formula. In particular, what we're going to try to prove, or what we're going to present a proof of, is we're going to prove that log of b to the base a is the same as log of b to the base c divided by log of a to the base c. Okay, so it's a change of base formula. It allows us to calculate a logarithm to a particular base in terms of, I suppose, in terms of the previous base, okay, and the value, okay, in terms of the previous base, okay, but to a different base. So it allows us to convert across bases. So for example, I could convert from base 10 into base 2, or I could convert from base 10 into base e. I can do whatever base conversion I want by using this particular formula. But let's just recall an important identity. So let's just recall what it means to be a logarithm, okay, what a logarithm is, okay. So let's say we have something like this. Let's say that we have that y is equal to a to the power of b, okay. Let's say something like this, okay. What is a logarithm? Well, a logarithm, okay, maybe I'll write this a different way, okay, because you can see that I'm already using a's and b's up here. So let me say I say something like this. Let's say that b is equal to a to the power of y, okay. So when we look at this particular expression here, what we're saying is that some number is equal to some other number raised to a particular power. And actually, all a logarithm is this exponent, okay? A logarithm is the exponent that a particular base needs to be raised to in order to equal a specific value, okay? So actually, this particular notation here is equivalent to saying that the log, don't forget the y is the logarithm, okay? That log of b to the base a is equal to y, okay? So this is really important for us, okay? Allows us to convert from a logarithm notation into its equivalent, I suppose, let's say, its equivalent exponentiation notation, okay? So once again, let's just keep in mind that all a logarithm is an exponent, okay? All a logarithm is an exponent. And that exponent is the power that a particular number needs to be raised to in order to achieve a specific value, okay? So let's have a look at this proof here. What we'd like to prove is that log of b to the base a is equal to log of b to the base c divided by log of a to the base c. In other words, the change of base formula. So let's look at this proof. So let's look at the proof. Okay. So let's just say let's say, for argument's sake, let m equal log of b to the base a. Let's say that we let m equal log of b to the base a. And what's the consequences of this? What does this mean? Okay, well, if m is equal to log of b to the base a, well, then what that means is, therefore, what we know in exponentiation form is that a to the power of m must be equal to b. That's what it means to be a logarithm, okay? Is that the log of b to the base a is what power should a be raised to in order to achieve the value b. Okay, so this is based on the definition. Okay, so now what we'll do is we'll just get the log of both sides. Okay, so if a to the m is equal to b, well then that implies that the log of a to the m to the base c to some other base must be equal to the log of b to the base c. Okay, these two things are equal. Okay, so that means that when I calculate the log of a to the m to a new base, that will be the same as calculating the log of b to this new base. Now we know that we have a particular rule which is in relation to the power rule when it comes to logarithms. Just keep in mind that what we have is the power rule, the power rule, and what the power rule says to us is that the log of x to the y to some base, let's say xy to some base z, is the same as y times the log of x to the z, okay? In other words, we can break the power or the exponent away from the particular number. So actually this implies that m times log of a to the base c is equal to log of b to the base c. And you can actually see what's happening here. This implies that m is equal to log of b to the base c all over log of a to the base c. But what do we know? We know that We know that m is simply, because we let m equal log of b to the base a. So therefore we have that log of b to the base a is simply equal to the log of b to the base c divided by log of a to the base c. Allows us to change our base. Okay, and I suppose that's our proof. Yeah, that's all we need to do. So we can change bases. So for example, if I want to change into base e from base 10, let's say, actually let's have a look at that. Here's an example. Okay, let's say a particular example. Let's say an example. Okay, let's say I have the log of who cares what the number is. Let's say the log of 26 to the base 10. Okay, but I don't want to work in base 10s. I want to work in the natural, let's say the natural bases. I want to work in base e. Okay, well then what I know is that this is the same as, this is going to be equivalent to the log of 26 to the base e divided by the log of 10 to the base e. Now actually from a notation perspective, okay, we let log of e we let log of e be equal to ln, the natural logarithm. So actually what we now have is that log of 26 to the base 10 is the same as the natural logarithm of 26 divided by the natural logarithm of 10. So you can see the way we've simply changed bases here. Okay, just as another quick example, let's say we have the log of, let's say, 128 to the base 2, and I want to convert this to base 10s. Okay, well this is the same as the log of 128 to the base 10 divided by the log of 2 to the base 10. Okay, so don't forget that in our definition that this is our b and this here is our a. Okay, so you can see here what we have is we have our b and we have our a and we have our new base. Okay, so guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope that this proof, the change of base formula when it comes to logarithms, I hope that this was in some way intuitive, and more importantly, I hope that was helpful for you. And thank you for watching. Okay, bye bye.